All right, hey guys, here another proof video here, number 12. I'm going to do this as an example. We're going to think, what equations can I create by looking at this diagram? Well, it's segments, so I can use segment addition postulate. I'm already thinking that, using segment addition postulate at some point. That's going to be step 2. Addition postulate, and we'll get back to that in a second. And how does the equation change? What property justifies that the change is valid? Okay, so getting started with a proof, step number 1, also 2. Remember, I can either write statements by looking at the given diagram. I noticed that from step 2 because I'm adding segment lengths. That's going to be segment addition postulate. We'll save that for later. I can also get started proof by my givens, right? My given premises here. Remember, if this is true, if ST equals Rn and IT equals RU, and they mark it up, IT and RU here, I want to prove that right, SI has to equal UN. And it will be, right, because kind of logically ST, right, they don't mark this up, but if I could here, ST is 1, 2, 3 tick marks. And RN could be 1, 2, 3 tick marks. I want to prove that UN. Okay, if this is true, then SI has got to equal UN. So then this here, SI has got to equal UN here. Okay, so anyways, there's my if as the givens here. And notice, this is what I'm accepting as true, right? I accept this as a given premise. It's got to be true. And what I notice here is that I pulled ST equals RN. I didn't pull it out through the diagram. They don't show me ST equals RN in the diagram. I actually drew it in. This is one of my given premises. Look at here. This is one of my givens. That's a given premise. So what can I write for my reason? Why it appears step number 1, I can write given. Okay, step number 2, right? You can ask yourself, how does this equation changed? What property justifies that change? Well, from step 1 to step 2, they're talking about a lot more complicated stuff. ST equals RN, it doesn't just change on its own. So from step 2, that means they must have gotten these equations from the diagram. Okay, so then the question is, sections 1, 2, 1, 3, what are some reasons that we have directly from diagrams that allow us to write equations? Well, what are these? These angles are segments. They're segments. Okay, so that means the segment addition postulate is our reason here on number 2, because what they're saying is SI plus IT, what can I say about it? It equals ST. And RU plus UN, RU, that is also segment addition postulate. So I can write in RN down there. Part plus part equals whole. Okay, part plus part equals whole. All right, so anyways, right, part IT plus part IS equals the whole ST. All right, so now I'm working through my chain of logic. How can I work through this equation to help me write equation number 3? How did my equation change? Well, I have SI and IT. Well, I have that right there. Very good. I have RU and I have UN. I have that right there. Very good. It's coming together into one equation. Okay, so there's only one thing that must be happening, and that is I'm taking SI plus RIT, and what else do I know about it? Well, it equals ST, and ST is up here. Look, it equals ST. So what I'm doing is I'm plugging this into this top equation here, SI plus IT, and I'm also plugging in what Rn must equal, because the segment addition postulate said it equaled Ru plus Un. And when we do that kind of plugging in, right, math teachers use that word plugging in right here. What they really mean is substituting. So that means from step 2 into step 1, because I have ST here, and it was down there, Rn, and then Rn was down there, I can take what ST and Rn are equal to and replace that in equation number 1, and that is the substitution, POE. Substitution, POE. Okay, step 2 into step 1. All right, so now, right, I have this equation, step 3. I want to build on it, okay? So this next thing said, I don't know, get an additional kind of like star here, but one of the things that was on your toolkit, the very last page of your toolkit says, oh, what am I saying here? Am I saying here something that's self-evident? And this isn't self-evident. IT doesn't necessarily equal RU, so, right, this isn't reflexive property right here. This is actually another given. Look, they broke up their givens. That's where we got that from. So that's a little bit tricky here. Givens don't need to be mentioned all at the same time, okay? So they're sort of building on it. If this is true, and I know the segment addition postulate says this, then I know this is true through substitution. SI plus IT has got to equal RU plus UN. Okay, then they're going back to the given. If I know this is true, that IT equals RU, you know what? They're going to have enough to finish the proof now. Okay, so if you ever see a final step, the final step of the proof was, if this is true, well, I'm going to build my argument down here to then prove